You see it everywhere, right? AI is getting smarter, faster, and more incredible every single day. But behind all those jaw-dropping headlines and demos, there's another story playing out. It's a story of scarcity, of skyrocketing costs, and, frankly, immense pressure. And you know what? This isn't just a big tech problem. This is a crisis that's going to affect everything from your cloud computing bill to the price of your next phone. So let's break it down. The progress is just amazing, no doubt about it. But it all comes at a price that's not always on the sticker. So, what really is the hidden cost of this intelligence explosion? That's the question we're diving into today. Because underneath every single mind-blowing AI demo, there's this silent hardware crisis brewing. It's this weird paradox, right? AI's potential feels totally limitless, but it's getting choked by some very real-world limits: price, power, and just simple availability. And let's be super clear here. This is not just some temporary supply chain hiccup that's going to fix itself in a few months. Nope. Top analysts from places like Tom's Hardware and TrendForce, they're all saying the same thing. This shortage is our new reality, probably until 2027. So just waiting for prices to drop, that's not really a strategy anymore. I mean, just to put this in perspective for you, if you wanted to buy NVIDIA's latest and greatest AI chips right now, you'd be waiting a full year to get them. A whole year. In the world of AI, where things change in a week, a year is basically an eternity. Okay, so let's get into the nitty-gritty of this squeeze. It's really a perfect storm, created by three huge pressures: the chips themselves, the insane amount of power they need, and the special memory they're hungry for. First up, power. The International Energy Agency is projecting that by 2030, data centers are going to be chewing through a staggering 945 terawatt-hours of electricity a year. That's more than double what we're using today. And the main reason for that jump? You guessed it, AI. Every new advanced chip is like a tiny, powerful space heater, and we're about to plug in millions and millions of them. Next up, let's talk memory. See, AI models are absolutely ravenous for this special super-fast memory called HBM. To keep up with that demand, manufacturers are actually shifting production away from the standard memory, the DRAM that everything else runs on. This creates this crowding out effect, and the result? Prices for standard memory have shot up by 171% in just 1 year. That price hike hits everyone, from big companies buying servers to you buying your next laptop. And then, of course, there's the chip market itself. NVIDIA has an absolute iron grip on this space, controlling 86% of the AI GPU market. That kind of dominance lets them pull in gross margins of over 70%. That's what our source material calls the monopoly premium. And it's a premium that every single customer is paying.
But here's the interesting part. All this pressure, it's also creating opportunity. A whole new breed of specialized AI chips is starting to pop up, ready to challenge the GPU's dominance, and they are built on a totally different philosophy. The biggest challenger is something called an ASIC. Now think of it like this. A GPU is like a flexible Swiss Army knife. It's pretty good at a lot of different AI tasks, especially training new models from scratch. An ASIC, though, that's more like a surgical scalpel. It is designed to do just one thing, like running a model that's already been trained, which is a process we call inference, and it does that one thing with absolutely brutal efficiency.
And this is exactly why big tech is pouring billions into making their own custom ASICs. I mean, look at Google's TPU. It offers almost 5 times better performance for the price, and it uses 2/3 less power than a GPU. Amazon's chip isn't far behind. We're not talking about tiny little improvements here. For their operating costs, these are total game changers.
Then you've got these things called FPGAs. These are basically reprogrammable chips. Their killer feature? It's something called deterministic performance. That just means they have a perfectly consistent response time, right down to the microsecond. So for industries like high-frequency trading or medical imaging, where even a tiny delay could be a disaster, FPGAs are absolutely non-negotiable.
And finally, there's this big move to the edge. So instead of sending all your data to some massive cloud data center, Edge AI uses these specialized chips called NPUs, neural processing units, to run the AI right there on your laptop or your phone. This is a huge money saver, it's way better for privacy, and boy is it fast.
So here's the crucial takeaway. It's not just about what chip you're using, it's also about where you're using it. The really smart strategies go way beyond just the silicon and start looking at the bigger picture of operational costs.
And wow, nothing shows this better than electricity prices. Just look at this chart. Running the exact same AI job in Germany costs nearly 4 times more in just electricity than it does in Hungary, and over 5 times more than in Vietnam.
This strategy, which folks call geographic arbitrage, is becoming a really critical tool for taming those AI costs. To see how this all clicks together, let's look at a real-world case. Midjourney, the AI image generator. They were facing this huge challenge where their operational costs, running on GPUs, were actually threatening to sink the entire business.
So what do? They made a really strategic switch. They kept using GPUs for what they're great at, training their models. But for that day-to-day grind of actually generating millions of images for users, that inference workload, they moved it over to Google's specialized TPU ASICs.
And the result? It was absolutely stunning. A 65% cut in their monthly compute costs. They went from spending over $2 million a month down to less than $700,000. Think about that. A single hardware decision basically saved their business model. Okay, so what does all of this mean for you? How can you actually navigate this super complex landscape? Well, the source material lays out a really clear, actionable playbook.
It's a simple 3-step roadmap. First, in the next few months, audit your AI workloads. Really understand what's training versus what's inference, and then analyze the total cost of ownership for alternatives. That means looking beyond just the sticker price. Next, over the coming year, you gotta diversify. Start deploying different kinds of hardware. Build a multi-cloud strategy so you're not locked into one vendor. And finally, looking out past a year, think about scale. Get your employee devices ready for AI, and start thinking strategically about where you host your services.
So, the most important point is this. The era of just relying on one type of chip from one company is over. It's done. A diversified multi-chip strategy isn't just a nice-to-have anymore, it's a necessity for survival. It's the key to slashing your costs by 30–50% and finally breaking free from vendor lock-in.
The tectonic plates of the AI hardware world are shifting right under our feet. That old GPU monopoly, it's fracturing. And a new, much more diverse ecosystem is rising up to take its place. The only question left is your strategy ready for it?